Hey everyone, and welcome. Today we're going to crack a code, one that's at the heart of algebra, the two-step equation. And trust me, mastering this is way more than just about passing a test. It's like a superpower for your brain, a tool for thinking logically that you can literally use anywhere. So let's jump right in.
So let me ask you a question, and it's a simple one. Think about what you did this morning. You put on your socks, then your shoes. Super obvious, right? Well, what if I told you that doing that simple thing in reverse, that's the secret key to solving these tricky-looking equations?
And that right there, that's our first huge idea. We're going to call it the reverse rule. See, to undo something, you can't just do things in any old order. You have to go backwards, step by step. You got to take your shoes off first, and then you can take off your socks.
It sounds so simple, but that everyday logic, that's the entire foundation for what we're about to do. All an equation really is a bunch of steps that someone did to a variable, to x. Our job is to figure out what x is, and to do that, we just have to retrace their steps, but backwards.
Now, I'm sure you've heard of PEMDAS or GEMDAS in math class, right? The order of operations. Well, to solve equations, we need a secret weapon, the reverse of that rule. It's like a secret code that's going to unlock pretty much any equation we come across.
Okay, so check this out. On one side, you've got building things up, simplifying. For that, you use GEMDAS. You know the drill. Groups, then exponents, multiply, divide, and so on. But solving an equation, that's like taking something apart. It's deconstruction, and for that, we have to flip the script. That's where SADMAP comes in. Notice how it's GEMDAS completely backward? We start by undoing subtraction and addition first. Then we tackle division and multiplication. We're literally reversing the order.
All right, let's try thinking about this another way, something more visual. Imagine our variable, the x, is like a really cool prize locked inside a couple of boxes, one inside the other. Our whole mission is just to unbox it, one layer at a time, to see what's inside.
So, how do we get the prize? Simple. We always start from the outside and work our way in. That outer box? That's any number just hanging out, being added or subtracted. We call it the constant. We get rid of that one first. Then you've got the inner box. That's the number right next to the x, the one being multiplied or divided, the coefficient. We get rid of that second, and boom! The prize is ours.
Okay, that's enough talk. Theory is great, but the best way to really get this is to just do it. Let's put our SADMAP code and our unboxing idea to the test with a few challenges. Ready?
All right, here's challenge number 1. 2x plus 5 equals 15. So let's think about what happened to x. First, it got multiplied by 2, and then someone added 5. So to find it, we just need to work backwards.
So, following our SADMAP rule, we deal with addition or subtraction first. We've got a plus 5 here. How do we get rid of it? We do the exact opposite. We subtract 5. And here's the golden rule of algebra. You have to remember this. To keep everything fair and balanced, whatever you do to one side, you have to do to the other. So we subtract 5 from both sides. That leaves us with 2x equals 10. See? The outer box is gone. Okay, time for the inner box. X is being multiplied by 2. What's the opposite of multiplying? Dividing. So we just divide both sides by 2, and that's going to finally get our x all alone. And there it is. X equals 5. We did it. We unboxed the prize just by following our rules and working backwards. Pretty simple when you think about it that way, right? All right, you ready for another one? This one might look a little different. We've got y divided by 3 minus 4 equals 1. But don't let it fool you. The process, the steps, they're exactly the same. We just trust our system. SADMAP.
So first things first, what's our outer box? It's that minus 4. To get rid of a subtraction, we do the opposite. We add. So let's add 4 to both sides. On the left, the minus 4 and plus 4 cancel each other out, and that leaves us with y divided by 3 equals 5.
And now for the final step, that inner box. Our y is being divided by 3. To undo division, we do what? We multiply. So let's multiply both sides by 3, and that will get y all by itself.
And there we have it. Y equals 15. See, it doesn't matter if it's multiplication, division, whatever. The system, the process, it works every single time.
Okay, you've been doing great. Time for a tricky challenge. A lot of people get stuck on this kind of problem. 6 minus 3x equals 18. The way it's written just throws people off. But you know what? If we just stick to our rules, we're going to be totally fine. Okay, pay close attention here, because this is the crucial part. Look at that 6 at the beginning. There's no sign in front of it. which in math means it's a positive 6. So, to get rid of a positive 6, we have to subtract 6 from both sides. But, and this is the part where everyone messes up, that minus sign in the middle, it doesn't just disappear. It belongs to the 3x. It's glued to it. So when we're done, we have negative 3x equals 12.
From here, it's easy. We just divide both sides by negative 3. And that gives us our answer. X equals negative 4. Boom! Nailed it!
All right, before we go on, let's talk about the most common traps people fall into. I want to give you some pro tips for success so you can avoid these mistakes that catch people out over and over again.
Okay, this is the big one, the absolute #1 mistake. Just like we saw in that tricky problem, people forget about that little negative sign. They do the first step and it just vanishes. You have to burn this into your brain. The sign to the left of a term stays with that term. It's part of its identity. It's stuck to it like superglue. So I know what some of you are probably thinking. This is cool and all, but am I ever really going to use this in real life? And the answer is yes, absolutely, all the time. You just don't realize it because lots of everyday problems are actually two-step equations in disguise.
Just think about taking a taxi or a ride share. There's almost always a flat fee just to get in the car, right? That's your constant, your outer box. And then there's a charge for every mile you travel. That's your coefficient, your inner box. So if the final fare was, say, $15, your brain automatically solves a two-step equation to figure out how far you went. You first subtract that flat fee, and then you divide what's left by the price per mile. That's SADMAP right there in the real world.
So there you have it. That's how you crack the code of two-step equations. Once you know the secret, SADMEP, and the idea of working backwards, you can solve just about anything. So I'll leave you with a final puzzle. Now that you know what to look for, what other two-step puzzles can you spot hiding in the world all around you? Thanks for joining me.